So it would be good if you all focus only on today's lecture, and the questions should also be related to today's lecture only. Please don't still remain in R, otherwise you will not be able to understand the basics of inferential statistics. Now, day before yesterday, when we were talking about statistics and how we classify it, we had discussed that broadly it is classified into two sections: descriptives and inferential statistics. Now, what is the difference between the two? I did explain it day before yesterday, that whenever we get any data, the first thing that is done to the data is descriptive statistics. Now, what descriptive statistics means? We try to describe our data. That is, we try to understand whether it is normally distributed or not, whether it is having outliers, whether it is having extreme observations, mean, median, mode, what is the distribution, and very basic understanding of the data. After we have understood our data, that is, after we have described our data, then we go into the second section, that is inferential statistics. Now, as the name suggests, inferential has come from the word infer. Okay. Now, what infer means? Infer simply means that you are drawing some conclusion about your population on the basis of the sample. Now, suppose if, now this is the refresher course that is going on, and we have participants from different streams. Okay. Now, suppose if I want to say generalize something about the youth of India, about the Indian youth population. Now, one way is that there are many youngsters and youth who have joined us in this refresher training program. So one approach could be that I can develop a questionnaire. I hope you all know what is a questionnaire, set of questions. I can develop a questionnaire. I can ask those questions from all of you. And taking you all as a sample, I can generalize my results for the entire India. This is exactly what inferential statistics means, right? We don't have information about the population. Sometimes it is impossible to gather information about the population. Sometimes we don't have that time, the money, other resources. So that is why it is difficult to collect information about the population. So there are like lot of reasons, and like lot of, I mean, because it is not possible to collect information about the population, the approach is that on the basis of a sample. Now, actually, what happens is whenever we study inferential statistics, it is also very important to discuss about sampling. Now, since like we have limited time to discuss about these things, so I am definitely not discussing sampling much in detail, but still I am explaining it to you in brief. What exactly sample data means? We try to collect a sample which is assumed to be a good representative of the population. Suppose if I want to like infer something about India. Now I will make sure that my sample has individuals from all the Indian states. Only then it will be a good representative. Suppose if only I have northern population, North Indian population, then how can I generalize it for whole of India? Suppose if I only have South Indian population, it would be wrong if I generalize the results. So it is extremely important to have a proper sample. Only then we can generalize the results about the population. So this is exactly what inferential statistics means. We have a sample. That sample, first of all, you perform descriptive statistics on that sample. Why you perform descriptive? Because we have to decide that which test has to be performed. Okay. After we have decided on that, then we go into inferential, and then we try to generalize our results for the entire population. Right? I hope the basic concept of inferential statistics
मैम
is clear. हाँ
मैम एक क्वेश्चन है।
हाँ जी हाँ जी
जैसे आपने कहा कि पहले हम डिस्क्रिप्टिव स्टैटिस्टिक्स देखते हैं कि
हाँ
हमारा डेटा नॉर्मली डिस्ट्रीब्यूटेड है या नहीं। व्हाट
राइट
आई वांट टू आस्क इज, if the data is scattered and if it is not normally distributed, we can still go to the next level of like inferential statistics,
yes.
right?
So it's a very very good question, Geeta. Actually, what happens is that I mean I think you are not from a statistics background.
I'm not. I'm a nutritionist.
Yeah. So this, I mean, there are a lot of other people from different backgrounds who come to us for statistical analysis, and this is a very, very natural and a common question that comes to everybody's mind: that what if our data is not normally distributed? Will we be able to perform tests? Definitely, the answer is yes. And let me tell you, I mean, let me take this opportunity to share with all of you. In real life, in practical situation, it is actually very difficult to get a normally distributed data. I mean, if Dr. Dharmend is here, he would definitely agree to what I am saying. When we were studying, our professors used to tell us that in real life, there isn't any data that is exactly normally distributed. Approximately normal distribution तो होता है, but exact normal नहीं आता. And इसी से we come to the classification of parametric and non-parametric test, जिसका की brief I will discuss with all of you. If your data, if your sample comes from a population which is normally distributed, we go for parametric testing procedure. While on the other hand, if it comes from a population which is non-normally distributed, that is scattered, which you said, then we go for corresponding non-parametric test. Both are equally good and both are used for statistical analysis.
Okay, ma'am.
Okay, I hope your doubt is clear.
Yes, yes.
Yeah. So coming to the next very important term which we talk whenever we talk about inferential statistics, and that is hypothesis. Now, any statement which we give about the population is known as hypothesis. The only condition is that the statement which you are considering to be a hypothesis should be capable of being tested. It should be a testable statement. I'll give you an example. Suppose if I say that participants who are attending this refresher course have an average height of 155 centimeters. Now, this is my hypothesis. Definitely, this hypothesis can be tested. How can I test? I can take all of yours height. I can take out the average and I can test that whether it is equal to 155 or not. Suppose if I say that sun would rise in the west or north, south, whatever. This is also a statement. But how can you test this statement? It is a universal truth. So always remember that universal truths or facts are not hypothesis. It is a statement. Some people, like in some books, hypothesis means educated guess. So yes, it is a statement. It is an educated guess. Why I'm saying educated guess? Because कुछ भी बोलने से पहले we need to have a backup of like it should be backed up by certain information. That information could be from different professors, from different books, anything. But so that is why it is called an educated guess. So what is a hypothesis? It is any statement which is capable of being tested or an educated guess. Okay. Now, these are some of the examples of hypothesis which we can test. whether one way of teaching is better than the other way of teaching, a new medicine that you think might work, any other statement or hypothesis which could be related to your field. One more thing which is very important here, and that is we classify hypothesis into two sections: null and alternative hypothesis. Now, what is null and what is alternative hypothesis? Null hypothesis always means hypothesis of no difference. Now, what do I say when what do I mean when I say hypothesis of no difference? Suppose if I say that the average height of participants who are attending this training program is 155 centimeters. This means that the average height and my estimation of height is the same. So, I mean, there is no difference in the height. That is called null hypothesis. So always remember, null hypothesis is hypothesis of no difference. While on the other hand, we have an alternative hypothesis, which is just the opposite of the null hypothesis. So always remember that hypotheses, they occur in pair. Okay, you will have a null and you will have an alternative hypothesis. Is this clear to everybody? Are there any doubts still here? Do we have to quote hypothesis in? Yes, you have to quote hypothesis in any study, even if it is observational, experimental. The aims and objectives we write. So whenever we write aims and objectives, it should be backed up with hypothesis. Okay. Going on to the next. So null hypothesis, it is a true statement about the population and there should be no difference between like null hypothesis is always the hypothesis of no difference. Alternative is always opposite to your null hypothesis. So always remember, hypothesis exists in pair. You will have a null and along with the null, you will have an alternative hypothesis. Now, this is an example of null and alternative hypothesis. Let us try to understand. When I've written null, I have written H0 or H0. This is called H0. So always remember, null hypothesis is represented by H0 or H0. Okay. So how have I written? H0 such that mu is equal to mu naught. Now, what is mu and what is mu naught? Mu is your average. Okay, we denote average by mu. So what actually this means, mu is equal to mu naught. Mu naught is any hypothetical value of average. So I have given you an example that the average height of all of you who are attending this training program is 155 centimeters. Okay. So mu naught will be 155 centimeters. ठीक. This mu naught can be your choice. It can be my choice. It can be the choice of the researcher, anybody. Okay. So what this means, mu is equal to mu naught. This means that I am testing for mean. Okay. And I am testing that whether mean is equal to 155 centimeters. So this becomes my null hypothesis. Contrary to the null, I can have three types of alternate hypothesis. आप पहली वाली भी ले सकते हैं, दूसरी वाली भी ले सकते हैं, and you can also take the third. Now, what is the difference between the three? Obviously, first one, I think everybody will understand. Mean is equal to 155 centimeters. Mean is not equal to 155 centimeters. ठीक है? So, first वाली तो हो गई two-tailed. This is called two-tailed alternative hypothesis. Why it is called two-tailed? If you see the figure on the right, or usme bhi please see the figure at the bottom. Two-tailed means that value could be on the left and value could also be on the right. मतलब ये हुआ हाइट 155 से कम भी हो सकती है और 155 से ज्यादा भी हो सकती है. ठीक है. दिस इज टू टेल्ड ऑल्टरनेटिव. हम लोग कब लेते हैं टू टेल्ड? when we are not sure that whether the height would be greater than 155 or it would be lesser than 1. When we are not sure, then it is always advisable to go for a two-tailed alternative hypothesis. Now, the other two possibilities are left-tailed and right-tailed. Now, what this means? Left-tailed means that values will be less than 155 centimeters. And right-tailed means that value would be greater than 155 centimeters. Now, there could be a question in like all of your minds that when should we take a two-tailed and when should we take left or right-tailed? When you are sure about the outcome or the result. What this means? Suppose if, suppose if we go in for a diet program, like there is a nutritionist who has joined our course. So suppose if she decides that she has taken 10 or 12 individuals and given them a certain diet for a weight loss program, and then after say 1 month, again she will take their weight and see that whether this diet has resulted in weight loss or not. ठीक है, ऐसा होता है. Suppose if this is your objective, then you obviously know, and your aim is that weight should be reduced. So in that case, we will go with one-tailed alternative hypothesis, and that is left-tailed, because you are assuming that weight will reduce. Am I clear? While on the other hand, suppose if my objective is to increase the weight. Weight is just an example, कुछ भी ले सकते हैं. So suppose if my objective is sort of that I will be giving certain diet to increase the weight. So in that case, I know that my alternative will be right-tailed alternative. So when you are sure, in that case we go for left or right tail. But when we are not sure, in that case we go for two-tailed alternative hypothesis. Any of the three you take, the results would not affect. It is, all the three are equally powerful. Okay? Is this concept clear to everybody? I hope I am not going too fast. And I'm also trying to explain it in very simple terms so that without less mathematics and statistics, we are able to understand this concept. So are you all understanding?
Yes, ma'am.
Yes, ma'am.
Okay. Any doubts that you have, you can ask.
Yes, ma'am. I just have one doubt. I was asking, like, usually people write like two-tailed only. Either mu is not equal to mu naught, or it is equal to. So they write. But is it like if you're taking one tail, then the p-value you cut off, usually we take 0.05. So if it is one tail, so should it be double of that, like less than 0.1, or it should be again less than 0.05?
Okay. Again, a very, very good question, Dr. Sangeeta. Mostly in whenever we do these kinds of analysis, especially using the softwares nowadays, in the software, it is very clearly written that whether they are assuming a two-tailed alternative or they are assuming one-tailed. In that case, if you are going for one-tailed and if the software is giving the results of two-tailed, then whichever value you get, you will have to multiply it by 2.
Okay.
Yeah, in that, I will explain it to you, don't worry. The good part about our software is it gives you in most of the testing, it gives you both p-value for one-tailed and it gives you p-value for two-tailed also.
Ma'am, I have an issue. I have a doubt here, ma'am. Can I ask?
हाँ बिल्कुल पूछ please
Okay,
please ask.
ma'am, since you have given the null hypothesis at mu equal to mu naught, so if there is more than one parameter, like mu and there is another mu or another sigma square, so this finding, then alternative hypothesis is based on the two parameters then, okay? Whatever
Yes,
it is,
will
let's
be.
still
Yes,
writing.
yes. So you will have one null hypothesis for one parameter. You will have another null hypothesis for another parameter. So for each parameter, we will have separate null and separate sets of alternative hypotheses.
Okay. So if you are going to test this kind of hypothesis in R, is there any function or availability of that specific function for solving this?
So what happens is for testing of mean, we have different tests. And just as you said, sigma or sigma square, which is variance. So for testing of variance, we have different sets of tests which are available.
Okay, it will be different. Thank you, ma'am. Thanks.
Okay.
Ma'am, I was just wondering, how will the software decide the mu naught values?
Sorry, please come a little louder.
How will the softwares decide the mu naught values, ma'am?
So the software, yes, Aishwarya, I'll explain. So the software doesn't decide the mu naught value. You have to give the mu naught value to the software.
Okay, ma'am. But how?
Yes, that researcher has to decide. And how does researcher decides? So either it is based on the previous, it is mostly based on previous studies only. Purane literature ko, we go through the previous literature and on the basis of those literature only we decide the value of mu naught. So generally it is based on previous studies only, but when you don't have previous studies या फिर बहुत सारा काम नहीं हुआ रहता है उस topic पर, so in that case, you can use your own decision. You can have a discussion with your professors, senior teachers, stuff like that.
Okay, ma'am, because I don't recognize like giving that mu naught value anywhere in SPSS, like SPSS was taught to us earlier,
In
no?
SPSS also we give that value. अगर SPSS पर आपने testing, if you had studied test one sample test in SPSS, there we do give a test value. That test value is mu naught.
Okay, ma'am.
So we have to give that value. Software will never be able to decide on its own. No software is able to. अभी तक तो नहीं है. Maybe this AI thing is going on. So I don't know what future holds. Maybe it will decide on mu naught. It will decide on everything, and it will give you the results. I don't know. But till now, we don't have any other way by which we can decide the value of mu naught. Okay.
तो मैम स्टैटिस्टिशियंस का यूज रहेगा ना अगर एआई सब डिसाइड करने लगे
I'm keeping my fingers crossed. As long as AI stays in the limit, statisticians will have their role. But I have no trust on this AI thing.
मैम
So
ये
it
क्या
can
बोल
even
रही
replace statisticians. Yes.
No, it will not replace.
हाँ, ये तो दो धारी तलवार है
Ma'am,
I
the
don't-
software gives you result,
I
but
think-
interpretation human brain only has to do.
Yeah.
I think we play the key role, ma'am. in generating
Thankfully people realize that everything software can do, but when to use which test, how to interpret it, these things, everything a software cannot, a machine cannot do. So yes, we do need statisticians for that.
क्या पता फ्यूचर में वो भी बन गया तो
हाँ, बिल्कुल. I have no trust on this AI thing. It can do anything. That is why I'm saying I'm keeping my fingers crossed. Okay. Now coming to
मैम
this.
वो म्यू जो है म्यू इज इक्वल टू म्यू नॉट में से म्यू जो है वो अपने डेटा से कैलकुलेट होता है क्या
हाँ, mu will be your sample mean.
ओके
Ma'am, in the slide, it is shown that mu is the population mean.
Yeah. I'm so sorry. Mu,
Oh, okay,
actually
okay.
what happens is, she asked this question that whether it is calculated from the data. So yes, it is calculated from the data. it is based on the sample observations, but it is the population mean. I mean, what do we say? We say that on the basis of the sample, we try to infer about the population. तो निकलता sample से ही है, the sample observations that you have, but you try to infer about the population.
Okay, ma'am.
मैम आपने कहा कि पॉपुलेशन नॉर्मली डिस्ट्रीब्यूटेड होगा तो हम पैरामीट्रिक यूज करेंगे, अगर नहीं होता पर वो
If the population is if the population is normally distributed, then we go for parametric tests. Otherwise, we go for corresponding non-parametric tests.
पर मैम पॉपुलेशन का डेटा नहीं होगा तो मतलब हमारे पास थोड़ा ही डेटा है, वो सैंपल है।
Population का डेटा होता ही नहीं है. That is why we go for inferential statistics. तो हम कैसे टेस्ट करेंगे कि पॉपुलेशन नॉर्मल है या नहीं? On the basis of sample.
Okay.
So what we say that sample is assumed to be taken from a population which is normally distributed.
मतलब
Is
सैंपल
clear?
नॉर्मली डिस्ट्रीब्यूटेड होगा तो पॉपुलेशन भी नॉर्मली डिस्ट्रीब्यूटेड
Yes. Since we don't have the data for the population, like suppose मुझे यही बोलना है कि इंडिया में the youth have average height 155 centimeters. Now I cannot take the height of each and every youth of India, right? I mean, whole India, that there will be so many youngsters. It will not be possible for me to take the height of each and every one. So, एक ये training program चल रहा है, and I have youngsters from all over India. So मैंने ये मान लिया that it is a representative sample, and on the basis of this sample, I will infer about the population. So since I don't have data about the population, so I will test the normality of this sample, do everything on this sample, and on the basis of this sample, I will draw inferences about my population or about the population which is to be tested.
तो मैम आप फिर यहाँ पर हाइपोथेसिस इसका कैसे डालोगे? म्यू इज इक्वल टू 155 बिकॉज यू आर अज्यूमिंग कि 155 एवरेज है.
Yes.
Okay.
And mu will be the population mean which will be taken from the sample.
Okay, जो हमारा रिजल्ट आएगा लेने के
Yes.
बाद, एक है जो पहले आप डिसाइड कर रहे हो कि आपको जो लग रहा है एस्टिमेटेड 155 है,
Yes.
और एक जो एक्चुअल आएगा. तो अब
Yes.
इसमें हमको पता नहीं ना, 155 से कम भी एवरेज हो सकता है, ज्यादा भी.
Yes.
तो फिर हम
And
ऑल्टरनेटिव क्या रख पाएंगे?
तो हम ऑल्टरनेटिव नॉर्मली इन केसेस में तो टू टेल्ड लेके चलते हैं,
Two-tailed.
सेफर
अच्छा.
साइड.
ओके ठीक है.
और मैम
Definitely,
अगर
just a second. Definitely, left or right tail is more decisive. Decisive as if कि मतलब you're sure, right? But since in most of the cases we are not very sure, so it is safer to go for a two-tailed alternate. Yes.
और अगर मैम वो नॉर्मली डिस्ट्रीब्यूटेड नहीं है तो वो कौन सा डिस्ट्रीब्यूशन फॉलो करता है, वो हम चेक कर सकते हैं क्या? मतलब
Yes, we can check the distribution also, but कई बार ऐसा होता है that we do not know that which distribution it is following. That is why it is called non-parametric test, because you don't have an idea about the parameters, you don't have an idea about the distribution. That is why it is called non-parametric test.
ओके. और जरूरी नहीं होता क्या कि वो कौन से डिस्ट्रीब्यूशन में से आ रहा है वो पता होना?
नॉर्मल है या नहीं ये जरूरी होता है. नॉर्मल के अलावा डेफिनेटली जब हम थोड़ी एडवांस्ड स्टैटिस्टिकल एनालिसिस पे जाते हैं, मतलब काफी एडवांस, तब डिस्ट्रीब्यूशन पता होना चाहिए. हाइपरजोमेट्रिक, ज्योमेट्रिक, एक्सपोनेंशियल, गामा, परेटो, वीबुल, देयर आर सो मेनी डिस्ट्रीब्यूशंस, बट दैट इज फॉर एडवांस्ड स्टैटिस्टिकल एनालिसिस. फॉर इन्फरेंशियल स्टैटिस्टिक्स जो हम यहाँ पे पढ़ रहे हैं, normal distribution is definitely very important. You should know whether it is normally distributed or not, because parametric test can only be applied when your sample is from a population which is normally distributed. I am repeating it once again. Today we will be discussing parametric tests only. आप लोगों ने शायद सुना भी होगा टी टेस्ट, paired t-test, independent t-test, ANOVA, all of these come under parametric tests. And for them,
Yes.
it is very important that population should be normally distributed. I mean, sample should come from a population which is normally distributed. So yes, normal के बारे में पता होना जरूरी है. अगर normal नहीं है, we just say that it is not following normal, and hence we go for its corresponding non-parametric test.
Ma'am, I have a question regarding this normality.
Yes.
Ma'am, I saw one case in SPSS that the supportable test it gave the value which showed that the distribution was normal, but there was skewness in the distribution. So can we consider it as normal, or shall we discard it as normal?
Now, these are two very different things which you are saying. Normally, if a distribution is skewed, it is not normal.
Yes,
it
but
depends.
the result showed that the distribution was normal, but
I have understood.
But it was skewed.
Please let
Yes,
me
ma'am.
complete. Normally, what happens is that if you have a large sample means if there are many observations, in that case, even if it is slightly skewed to the left or right, still it is normally distributed. I mean, still it comes under normal distribution curve. So, ऐसा नहीं होता कि exact symmetrical होगा. That is why I said that it should be approximately normally distributed. So maybe because of the sample size, it might be slightly skewed, but still in the testing, it is coming normally distributed. You will blindly follow the results of the test and you will assume that it is normally distributed.
Okay, ma'am.
Okay, so if we are applying any test of hypothesis, then you should blindly follow the results of the test and don't look at the graph. Tests are always decisive. Okay. So I hope we don't have any other question. Is it better to use always two-tailed or both can be mentioned? There isn't anything, Nikita, like which one is better or not. You can go for a two-tailed, you can go for one-tailed. It actually depends on your objective. If you are sure that you will have a result which is increasing or which is decreasing, then we can go for one-tailed. But if we don't know that whether it would increase or decrease, then we should go for two-tailed. Both of them are equally good. Okay. So now, again, very important concept here. Now, when we talk about testing of hypothesis, there are these two kinds of error that occur in testing of hypothesis, which are called alpha and beta. Alpha is called type 1 error and beta is called type 2 error, if you can see on my screen. Now, this alpha is only called level of significance or probability of type 1 error. Now, what happens is, I mean, why is this type 1 error? Now, if you can see the screen, what happens is, one is the truth, that whether the hypothesis is actually true or not, and one is your finding. So what happens is, if the hypothesis is true, but your finding suggests that it is false, then it is an error. This kind of error is called type 1 error. While on the other hand, if your hypothesis is actually false, matlab height actually 155 nahi hai, but matlab truth, the fact is that height is not 155, but your results say that height is 155, that type of error is called type 2 error or beta. Why are we discussing about these two errors? In testing of hypothesis or inferential statistics, it is important to minimize these two types of error. A good test of hypothesis is one in which these two types of error are minimum. Now, the problem is that you cannot minimize both these errors together. You cannot do that. You will have to fix one type of error and minimize the other. So what happened is, after a lot of discussions among statisticians, lot of after a lot of thinking, what was finally decided was that type 1 error is more serious as compared to type 2 error. And that is why type 1 error was fixed and we tried to minimize type 2 error. So this alpha or level of significance, which you all have heard so many times, 0.05, 5% error, this is called type 1 error. So what exactly 5% error means? 5% error means that if you are going to do this thing 100 times, 95 times you will get the same result. Only 5 times you will get a result which is different. This is what type 1, this is what 5% error means. 95 times out of 100 you will get the correct result and 5 times you will get an error. Only 5 times. So every time now, whenever we will do testing of hypothesis, we will come across this. I will be repeatedly using level of significance 5%, alpha 5%. This means that type 1 error is assumed to be 5%. That is, if you do it 100 times, 95 times you will get the same result. 5 times you can get an error or different type of result. I hope this concept is broadly clear to all of you. So these are some of the parametric tests which most of you must have heard. T-test, ANOVA, Z, F. F is for variance, always remember. Chi-square is one test which is both parametric and non-parametric. कुछ chi-square का use parametric के लिए होता है and chi-square is also used for non-parametric. So when we discuss chi-square in detail, I mean the non-parametric use, then I will explain it to you that how it is used as non-parametric. For parametric, it is used for testing the variance. So just now, I think someone mentioned that sigma is equal to sigma square. So जैसे right now, I had given you the example for mean. Mu is equal to mu naught. That is for mean. Similarly, you can test for variance also. Day before yesterday, we were discussing that there are measures of central tendency, mean, median, mode, and there are measures of dispersion. So you can check for variance, you can check for mean. If we check for mean, we generally perform t-test, ANOVA, z-test. But if we test for variance, then we perform either chi-square or f-test. Okay, is this clear? We have one question on the chat. Madam, can you explain another example for type 1 and type 2 error? Another example for type 1 and type 2 error. Suppose if a person has committed crime, but the judge decides that he is innocent. That is type 1 error. Actually, a person is criminal, but he is set free. That is type 1. And type 2 is that he is innocent, but he is found guilty by the court. That is type 2 error. Is this example clear, Mr. Gopi? Okay.
हाइट का एग्जांपल ही बताइए ना फिर से.
हाँ,
हाइट का एग्जांपल बताइए ना फिर से वो.
हाइट का एग्जांपल से अगर मैं बताऊं तो हाइट 155 है, लेकिन आपका रिजल्ट बता रहा है 155 नहीं है. That is type 1. Type 2 is एक्चुअली हाइट 155 नहीं है, बट आपका रिजल्ट बता रहा है 155 है।
मतलब टेस्ट करके रिजल्ट आया वो बता रहे।
Obviously, madam, your finding means after the results of the test.
ओके,
Is this clear, Aishwarya?
यस मैम।
Okay. So some of the t-tests, some of the parametric tests that we were discussing. So I said T, ANOVA, Z, all of them are used majorly for testing of means. Chi-square and F-test is used for testing of variance. These are some of the uses of t-test. One sample t-test, I think just now we discussed, height is equal to 155 centimeter. That is one sample t-test. Independent sample t-test. When we have two independent groups, for example, if I say height of male population in this class, in this training program, is equal to the height of female population in the training program. That is two independent t-tests. I am repeating it. Height of male participants or male population of the class is equal to the height of female population of the class. That is two independent sample t-tests. Then what is paired t-test? I gave an example that suppose if there are 10 individuals and they are all given certain diet and they are followed for 1 month. After 1 month, their weight is again taken, that whether the diet has resulted in weight loss or not, that is an example of paired t-test. So broadly, t-test can be used in 3 different ways. One sample t-test, independent sample t-test, and paired t-test. Okay. Then it can also be used for testing the significance of correlation and regression. This is a slightly advanced statistics, which is beyond the scope of this course. But maybe if somewhere you come across these terms, then you know. T-test is also used to test for the significance of correlations and regression. But majorly, we will be focusing on one sample t-test, independent t-test, and paired t-test. Please understand the difference, everybody, please understand the difference between independent and paired. Independent, so both of them are two sample. Why two sample? Because we are taking two groups. But for independent, we have two separate groups, like male, female, North Indian, South Indian population, like this. But for paired, we have same set of individuals, but their results are collected after time gap. So paired means dependent. Okay, so you have same set of individuals. Today you are taking their height, weight, or anything. Then after after 1 week, 1 month, 15 days, whatever, you are again taking their height, and then you height, weight, whatever, and then you decide whether it has reduced or increased. So that is paired. Both are two samples, but there is fundamental difference between the two. I hope it is clear to everybody.
Yes,
Ma'am,
ma'am. Just
in
one
case of
sample t-test, sorry. One sample t-test में आप एक बार वापस बता सकते हो कि हम जैसे अभी टू इंडिपेंडेंट सैंपल में हम बॉयज गर्ल्स में या जेंडर वाइज डिफरेंस देख रहे हैं, पेड में हम बिफोर आफ्टर देख रहे हैं, तो वन सैंपल में लाइक वी आर जस्ट इन्फरेंसिंग दैट ओवरऑल पॉपुलेशन का क्या हाइट है एज यू हैव। ओके, जैसे आपने पहले बोला कि मीन 155 है, तो बस वही वन सैंपल टी टेस्ट से हम चेक करें कि मीन 155 आ रहा है या नहीं।
यस,
ओके ओके,
एब्सोल्युटली करेक्ट।
ओके
ma'am, in case of independent sample t-test, we are taking two different groups, but you are working on only one variable, right?
Yes.
Okay.
Two sample means there, I mean, they could be on the basis of gender, they could be on the basis of their state, they could be on the basis of their class, graduate, postgraduate. मतलब कोई एक classification का variable होना चाहिए. You should have one classification variable, but it should be either on the basis of their height or weight or anything that you want to test between the two groups.
Ma'am, so the variable can means it can be nominal also or ordinal also.
Nominal can be the categories, like gender is nominal.
Yes.
So
Ordinal.
nominal can be categories,
Okay.
but variable has to be continuous. Okay?
Yes, ma'am.
मैम
मैम आप
मैम बस एक चीज
मैम आपसे एक रिक्वेस्ट है, जो भी क्वेरी है वो उनको आप लास्ट में करिए मैम. एक्चुअली टाइम निकल जाता है फिर.
जो क्वेश्चंस है उनको लास्ट में लें.
यस मैम.
Okay. Some people say that I should take it in the last. Some people say that we should have simultaneous question answers so that the doubts are clear. So, I mean, you all can decide and write on the chat box that what most of you want, and maybe then I can decide. Okay, any other question?
मैम बस वो
Yes.
आप एक बार बता दो, आपने ना नीचे वो लिखा है ना जो एडवांस के लिए, जैसे रिग्रेशन मॉडल्स और कोरिलेशन कोएफिशिएंट, ये इंडिपेंडेंट पेड टी टेस्ट या जो भी हम लगा रहे हैं उसके आगे ये यूज होता है.
Yes.
ठीक है. ऑलराइट.
Ma'am, can I ask one question?
Yes.
Supposing you have one group, but you want to say, for example, you're testing two teaching methods, but the same group we are testing two different methods of teaching, and then what test will be applied there? Supposing it is on scoring system. The result of that.
If you have same set of individuals and
Yes.
you are giving two different methods of teaching, so you will definitely not be giving two different methods at the same time.
Not at the same time. Maybe one we do it first, and then after, like, we do it
So
after
it
15
is a paired, then it is a paired sample.
But the methods are different.
No worries, but the individuals are the same, right?
Okay.
If you are doing it on the same set of individuals, it is paired.
Acha, I used to feel ki paired means it is before after, like
Not
some
necessarily
intervention.
before and after. Mostly, yes, it is before and after only. Mostly, yes, but yeah, but generally, if you have same set of individuals,
Okay.
so in that case, it should be paired.
Okay, ma'am. Okay, ma'am. Thank you.
Okay. Now, these are some of the examples of, some of the assumptions of t-test. This is basically assumption for all the t-tests, not for one sample or independent or paired. This is for mostly all the t-tests. पहला वाला तो आप समझ लीजिए the most important assumption. It should be normally distributed. Then the groups should have equal variances. Now this equal variance is mostly for independent t-test. I will show you how we do it on the software and then you will understand. Data should have independent scores. Independent scores basically means that each observation should be independent of each other. Independent of each other means that my height is in no way related to your height. Your height is in no way related to your friend's height. So मतलब एक observation should be independent of each other. Data should not have any outlier because generally if it is normally distributed तो outlier नहीं ही होगा. So outlier भी present नहीं होना चाहिए. And the last assumption is that it should either be collected on interval scale or ratio, which means it should be quantitative in nature. तो जैसा height, weight, इस type के examples मैंने दिए. So normally we perform t-test on variables which are quantitative in nature. I hope these assumptions are clear to all of you. Now, this is one sample t-test. So, Yes. So this is one sample t-test. Now you have a null hypothesis and you have alternative. 2-3 एग्जाम्पल मैंने दे रखे हैं स्लाइड में, आप देख सकते हो. Test whether average monthly profit of company is $140. Test whether average systolic.
आउटलायर क्या होता है?
Is there any question, Komal?
Yes, ma'am. What is outlier?
I am not able to hear you properly.
Ma'am, she is asking what is outlier.
Outlier is any value which is behaving slightly different from the rest of the data. It could be higher, it could be lower. We had discussed it when we were discussing box plot. So any value which is either high, either on higher side or on the lower side, behaving differently from the rest of the data set. So these are some examples of where we can use one sample t-test. Now this is the formula. I am not going into the formula how we do it because this is statistics. So we are not going into that detail. Just remember, you will have to solve it and then you will get a value. And on the basis of the value, we decide that whether we have to accept the null hypothesis or reject. कैसे decide करते हैं? This we will discuss when we do it on the software tomorrow. Then we have independent t-test. Here hypothesis is slightly changed. अब अगर आप देखें तो hypothesis is slightly changed. Here it becomes mu1 equal to mu2 because we have two independent groups. So the example of null hypothesis could be that there is no significant difference between average income of male and female. मतलब null hypothesis हमेशा no difference की होती है. So we can say that there is no difference in the height of male and female. ऐसे करके कुछ भी बना सकते हैं. So this is the null for independent sample. And then you have alternatives. Again, it could be two-tailed, left or right, depending on your objective. This is the test. This is how we solve it. Then this is paired. Now, for paired, there is a slight difference in your null hypothesis and alternative. This actually works on difference. These are paired samples, मतलब dependent भी बोलते हैं इसको, paired भी बोलते हैं. Simple words में before and after sample होता है ये. Okay, and how your null hypothesis changes? For paired, it is generally written as mu d equal to 0. Now, what is mu d? It is the mean of difference of paired observation. So, for paired t-test, we calculate the difference. दो sample हैं before after. We try to calculate its difference, and on the basis of difference, the null and alternative hypothesis is prepared. So it is just a way of writing. It is based on two samples. Both the samples have to be paired, but the hypothesis is framed on difference. Okay, you can see the example of paired t-test here. There is no significant difference between blood pressure before and after treatment. ये चीज हमेशा याद रखिएगा that null is always no difference. No difference or equality कुछ भी कह सकते हैं. So there was some treatment which was given and blood pressure was taken before and after the treatment. I hope this is clear example. This is how we solve it. Yes. Now the last parametric test where we will be ending today's lecture, and that is ANOVA. ANOVA is basically an extension of independent t-test. One simple line जो कि सबके mind में set हो जानी चाहिए. Analysis of variance is an extension of independent t-test. Now, why I'm saying it is an extension of independent t-test? In independent t-test, we frame our hypothesis as there is no difference between the two groups. है ना? Just now I said the average of male height, yeah, the average height of male is equal to the average height of female. This is an independent t-test. Suppose if I say the average height of North Indian population is equal to South Indian population is equal to Eastern Indian population, which is equal to Western Indian population. Suppose instead of
मैम आपकी
two
आवाज
groups,
नहीं आ रही.
I have 4 groups. Suppose if instead of 2 groups, I have 4 groups or like more than 2 groups, then we perform analysis of variance. And why it is called one-way ANOVA? Because we test one factor, I mean height. Agar height ke saath saath we also test weight, then it will be called two-way ANOVA. But it is a generalization of t-test because in t-test we tested for 2 groups. In ANOVA we tested for more than 2 groups. Is this clear to all of you?
मैम टेस्ट तो मीन करते हैं, तो एनालिसिस ऑफ वेरिएंस क्यों कहते हैं?
Very good question. टेस्ट तो मीन करते हैं बट एनालिसिस ऑफ वेरिएंस क्यों कहते हैं? Now what happens is when we do this testing, the concept behind this testing is that we try to find out whether there is any difference in the mean or not. यही तो टेस्ट करते हैं, that whether the average height for all the 4 regions, मतलब हम ये लेके चल रहे हैं north, east, west and south. Suppose for all the 4 regions, whether the average height is equal or not. Now we are trying to test that whether the mean is equal or not. If the mean is not equal, then there will be some variation in the height. What is the cause of that variation? Whether that variation is because of region or whether that variation is unexplained or random. So basically what analysis of variance does, it tries to find out the reason for variation. The reason for variation in the average height. Whether that reason for variation is due to the different regions. अगर region है, then जो भी आपने hypothesis बनाई, that is good. कि मतलब north, east, west, south में there is a difference in the height. So it tries to find out what is the cause of that variation. Whether the cause of the variation is the factor that you are studying or the cause of the variation is random, unexplained. So analysis of variance basically tries to find out the cause of variation. Is this clear?
Yes, ma'am.
It's a very, very significant question, I must say. And this question will be clear to, the answer to this question will be clear by this figure. This is what ANOVA does. It tries to partition your variation into 2 major parts. One is due to the factor that you are studying, and the other is just random, error, chance, and so on. Okay?
मैम दिस मीन्स इसमें फिर आपको करेक्शन लगाना पड़ेगा ना, बिकॉज
क्या करना पड़ेगा?
करेक्शन लगाना पड़ेगा.
What do you mean by correction?
Okay, so if the heights are different in 4 regions, it could be not because of the regional difference, it could be because of different ethnicity.
Yeah, but then we are not taking ethnicity into consideration. All the other factors, we would just put them into randomness. unexplained, error, random. Why unexplained? Because we are not taking it into consideration.
No, my question is if the difference is due to some other reason,
Yes.
then also it will show difference. And how do we say that difference is not due to the region, but it is due to some other reason?
Then it will not show you the difference. Because we are only testing that whether the difference is due to the factor you have taken into consideration or not.
So if I want to say it is the confounding variable, if I want to say that.
It could be a confounding variable, it could be an effect modifier, it could be anything. You are not taking it into consideration.
Then it will give a false result, no?
Yeah, because your objective is only related to the factor under study, that whether the variation is due to regions or not. You are not concerned about anything else at this particular point. I mean, our objective is only region.
Yeah,
we have to stick to one thing, right?
Then how do we
So
remove
it is
the
not because
confounders?
of the region, but itna to humko pata chal gaya that if there is a variation, it might be because of some other factor, but definitely not because of region.
Say, for example, a patient means we take patients who have myocardial infarction, heart attack,
Yeah.
and we want to study the relationship with hypertension.
Yes.
And then we study groups, and then we study hypertension is linked to myocardial infarction or not. But diabetes is a great confounder there.
Yes, it is.
So if we are not taking diabetes into consideration and one group has more diabetes than the other, we might feel that the difference is real, and we might say that hypertension is connected to myocardial infarction, which may be not true because diabetes was a confounder.
Yeah.
How do we, correct
address
that?
this kind of an issue? What happens is, now you know that hypertension is related to myocardial infarction, or it causes myocardial infarction. What happens is, you must have heard of this term which is called controlling. We try to balance both our control and cases in such a way that you have equal, I mean, suppose if gender is a cause which could be a confounder or an effect modifier, diabetes could be a confounder or an effect modifier. This is what happens. You try to balance your control and cases in such a way that only focus should be on hypertension and myocardial infarction. Taking all those confounders and effect modifiers as, I mean, this is what is called balancing while taking cases and control. That in such a way we take our case and control that only the cause and the effect. So we are only focusing on whether hypertension is causing myocardial infarction or not.
No, but that is true, ma'am. But if it is a multifactorial, we know most of the biomedical research is multifactorial problems.
Yeah.
So it's not possible to always control the data.
Yeah, I know. But then if it is not possible to control, then we set up multiple hypotheses, number one. Number two, there are ways by which we can also take into consideration effect modifiers and confounders. That is definitely not one way ANOVA. There are multi-dimensional analysis, then you have latent factor analysis and all those stuff. I mean, advanced statistical analysis. So whenever we need to deal with multifactorial problems or multi-factor problem, in that case, one way ANOVA is definitely not the answer to that problem.
Regression analysis could be an option, ma'am.
Regression, again, yes, it could be, but sometimes in regression also multicollinearity is an issue. There is one concept which is known as a structural equation modeling, SEM, that is done using AMOS. That is an answer, especially when we deal with multi-factor problems. You can have a look
I think
at
that is
that
beyond
once.
the purview of.
Yeah, I know it's beyond. I mean, it's little advanced, but then if you are going in for multi-factor problem, then you should try to just maybe go through all these advanced statistical techniques. You can just read, I mean, go through them No need of going into much statistics. Yeah.
मैम आपने
Yes.
बोला कि अनोवा कॉज ऑफ वेरिएशन बताता है, तो इसको आप थोड़ा सा एलैबोरेट करोगे क्या प्लीज?
Can you please repeat your question, Geeta?
यस, आपने बोला कि अनोवा जो है वो कॉज ऑफ वेरिएशन बताता है हमको, तो ये कॉज ऑफ वेरिएशन को थोड़ा एलैबोरेट करोगे क्या प्लीज?
Cause of variation मतलब whether that variation is because of the region.
ओके,
So north, east, west, south. Whether the variation is because of the factor you are taking into consideration, that could be the region.
अच्छा, ओके ओके, तो ये हमको अनोवा से पता चलता है।
ये हमको अनोवा से पता चलता है। ये दो में उतना इंपॉर्टेंट नहीं होता, दो मतलब दो ग्रुप्स में।
हाँ,
So that is why we go in for t-test. But when there are more than two groups, then variation due to that factor, I mean, it is important to understand, and then we go for variation partitioning. And that variation partitioning is done using ANOVA.
ओके। जैसे भी अनोवा में आपने चार चीजें बोली कि हम चार रीजन को कंपेयर करते हैं, तो इफ देयर आर
चार को
लाइक
कर सकते हैं, दो से अधिक होने चाहिए, बस दैट्स ऑल।
मे बी 6, 10, 12
Yes,
जितने भी
yes,
हो कर
yes,
सकते हैं।
yes.
अच्छा, ओके ओके।
So I hope we are done for today, and I hope the
Yes,
lecture was
ma'am.
not
Yes,
boring
ma'am.
with all of you.
Ma'am, if we
No,
are done,
ma'am.
just a small quick question, if I can.
Please, Dr. Gupta, go ahead.
Ma'am, like when we do drug trials, we generally use the term non-inferiority trials, superiority trials, and randomized trials.
Yes.
Which one would be better? Because one is inferiority trial, which is less than, superiority trial, which is more than, and one which is two-tailed. So in specific, because you have been specialized in biomedical research, so which of the three, randomized trial, inferiority or superiority, in regards to drug trial specifically? Any comments on that?
Randomized trial is definitely the best and cannot be compared to superiority or non-inferiority trials. In fact, even if it is a superiority or a non-inferiority trial, it has to be a randomized one. So randomized is something which is very different.
Right.
Coming to superiority and non-inferiority, there are a lot of doubts that people have that whether we should go in for a non-inferiority or superiority. Reading several books and literature on this, I can conclude by saying that no one is like, both of them are equally good. Having said that, you should be aware of the objective that you are dealing with. If in the objective to establish superiority is your objective, then I mean, if you have to just categorically prove that a particular drug is superior to the existing drug in the market, and categorically, if that is your objective, having read the literature, having gone through all the things in the past, then you should go in for a hands down, you should go in for a superiority trial rather than going in for a non-inferiority or an equivalence trial. But if you don't have enough evidence to sort of prove your superiority trial, or rather prove superiority of your drug, and even if we go in for an equivalence or a non-inferiority, that can also be enough to cater to our objectives, then we can go in for non-inferiority or equivalence. So it purely depends on how much support you have from the literature, how much evidences you have regarding the drug that you are doing. So, I mean, these results cannot be generalized, but if you have enough evidences and all the support, you should hands down go in for superiority. But again, having said that, it is not every time possible to go in for superiority. That is why you must have read various literature where people go in for non-inferiority or equivalence, because it is, I mean, it is a safer a safer bet.
So equivalence and non-inferiority are same, ma'am?
No, there is a difference.
Means,
There is a difference.
What is the difference? Means just to understand.
There is a huge difference between the two. That's another school of thought. I would not be going into much detail there. Maybe we can have a discussion on that later on. I can explain this to you with the help of some examples.
Ma'am, I have a silly question.
Yes, Utkarsh, go ahead with silly question.
Ma'am, I want to ask that the person who does lab tech यार डेटा एनालिसिस का मैम कोर्स कौन करता है? मतलब कि जो टेक फील्ड में जाते हैं या फिर जो लैब टेक्नीशियंस होते हैं
नहीं
मेडिकल
नहीं,
फील्ड
लैब
के?
टेक्नीशियंस को जरूरत नहीं होती। डेटा
यस मैम।
एनालिसिस का कोर्स तो वो करते हैं जिनको डेटा साइंटिस्ट बनना होता है,
यस मैम।
या फिर
Researchers.
जिनको बिजनेस एनालिस्ट बनना होता है, डेटा
यस मैम।
एनालिस्ट बनना होता है। इन ऑल दीज मल्टीनेशनल ड्रग फार्मास्यूटिकल इंडस्ट्रीज, companies like this, they, I mean everywhere now they require data analysts, क्योंकि अब सब जगह डेटा बेस्ड डिसीजन मेकिंग पर वी आर मूविंग टुवर्ड्स, तो इसलिए
यस मैम।
एवरीवेयर डेटा एनालिस्ट आर रिक्वायर्ड, तो वहां पे डेटा एनालिसिस होता है।
ओके मैम।
आप क्या कर रहे हैं? व्हाट आर यू डूइंग?
मैम बीटेक।
बीटेक, ओके। तो अब तो बीटेक भी डेटा साइंस में होता है।
यस मैम।
हाँ, दैट्स अगेन अ
पर
खतरा
मेरा
दैट वी आर
इंटरेस्ट
फेसिंग।
एनालिसिस में नहीं है।
कोई बात नहीं, तो वो सब के लिए हम हैं। We have a question in the chat from Dr. Ritvik. Ma'am, usually the researcher will be interested in accepting the alternative. Then why is it like any difference in mean is by chance, or is it depends on the question we have to answer in our research? It is not necessary that researcher is interested in accepting the alternative always. ऐसा हमेशा नहीं होता है। What happens in case of ANOVA is that either the variation is due to the factors. Okay. Suppose if your alternative is accepted, alternative means that variation is due to the factor. In case of ANOVA, alternative means that variation is due to the factor under study. So null means that variation is, there is no variation, and alternative means that variation is due to the factor. तो अगर नल एक्सेप्ट हो रही है, इन दैट केस वी से दैट अगर वेरिएशन होगा तो वो बाय चांस हो सकता है।
मैम इसमें अगर if there is a non-inferiority trial, even then the null hypothesis will be both drugs are equal.
Yes. Rather we say that it is non-inferior. हाँ, equal भी कह सकते हैं। Yes. Can extrapolation lead to increase in the beta error? Yes, it does. That is why it is not advisable to go in for extrapolation. But sometimes we don't have an option. That is why we go for extrapolation.
Ma'am, one question related to R. Ma'am, tomorrow can you please show how to import the data set from Excel or other?
I will show it to you tomorrow.
Okay, ma'am. Ma'am, because today I tried it, but there was no option to run the code in the command window.
Don't worry.
Yes.
We will
Yes,
do
ma'am.
it tomorrow. Don't worry.
Okay, ma'am. Thank you, ma'am.
Yes, thank you.
थैंक यू मैम।
मैम,
हाँ
हेलो।
हाँ जी।
एक्सप्लोरेटरी डेटा एनालिसिस एंड डिस्क्रिप्टिव स्टैटिस्टिक्स, इसमें क्या डिफरेंस होता है?
क्या फिर से पूछिए ऐश्वर्या।
डिस्क्रिप्टिव स्टैटिस्टिक्स, उसमें भी हम समरी मतलब सब निकालते हैं डेटा का समरी, और एक्सप्लोरेटरी डेटा एनालिसिस में क्या डिफरेंस होता है?
कोई डिफरेंस नहीं होता खास। EDA is descriptive statistics. Actually, EDA comes under the umbrella of descriptive statistics. Descriptive statistics is a bigger this thing. उसमें skewness भी आ जाता है, kurtosis भी आ जाता है, बहुत सारी चीजें आ जाती हैं। So EDA comes under the umbrella of descriptive statistics.
Okay.
Okay. So thank you all so much, and